Okay, today we're going to start talking about arithmetic sequences. Arithmetic means we're adding the same thing every time. So here we have an example. Now these should be relatively old hat. So -5 plus 3 is -2 plus 3 is 1 plus 3 is 4, 7. This is not an arithmetic sequence, but it is a sequence. 1, 1/4, 1/8, 1/16, 1/32. This one, 1, 2, 3, 5. That's the Fibonacci sequence where you add the previous two. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 would then be 13. Okay, so those are some basic sequences. Um, we're going to use both recursive and explicit formulas. So this is a recursive formula given 5 times un plus 1 plus 2. This is not an arithmetic sequence, it's just a sequence. Find u2, 3, 4, and 7. So un minus 1 here, this just stands for the previous term. So I need u2. 5 times the previous term is u1, which is 2, plus 2, that's 12. u3 equals 5 times 12 plus 2 equals 64. U4. The rule used here is this one that I'm using. So 5 times 64. That's 322. U To get to U7, I need to do U5 and U6. And then we'll get U7 over here. 5 times 322 plus 2 for U5. 1612. And I can just use previous answer on my calculator, but 40,312. I added wrong. I added 2 twice. And when you're doing a recursive formula, if you add wrong here, you get everything else wrong in the future. So important to be careful. But yeah, I did 5 times 12 plus 2, gave my number, and then did that number plus 2 again. So I guess I know where I screwed up, but okay, be careful. There's also explicit formulas which allow you to jump straight to like the seventh thing. So here, this one is a little easier. N, N being the term number, so U2 here, or U sub 2. N is 2, that's 8. U sub 3, that's 15. Here a mistake does not affect my next ones. Still ideal not to make them, but 4 squared plus 16, 24. 49 plus 2 times 7. 49 plus 14 is 63. Okay, that's a little introduction to sequences. Arithmetic sequences are ones that have a common difference. Means we add the same thing every time. So here we've got plus 2. Here we've got plus 1/5. Here we've got plus 4x. Here we've got square root of 2. All of those, I'm adding a square root, so I've got 1 plus 1 square root of 2, 1 plus 2 square root of 2, 1 plus 3 square root of 2, adding a square root of 2 each time. That's kind of an odd arithmetic sequence. But welcome to IB, where kind of odd is just normal. So, show that this is an arithmetic sequence. Well, we're adding -2. To show it, you show that the common difference. So what they're doing here is -13 minus 11 as a common difference of -2. -9, -11 minus -9. All of those have the same common difference, so they are arithmetic. I'm going to skip down to example 3. This is a pretty simple lesson, and we get lots of weird names here because this is an international baccalaureate course and trying to be very international. Nudrat is training for a marathon by running 1 kilometer further each week than she did the previous week. How far, determine how far Nudrat will run on the 20th week if she runs 2 kilometers her first week. So she's adding 1 each week. The easiest way to do this is probably write the arithmetic or the explicit formula, which can follow this general form. Nope. First term, which in this case was 2 plus d times n minus 1. So I'm looking for the 20th week. Her first week was 2. My common difference is 1. 20 minus 1 is 19. 1 times 19 is 1. 2 plus 19 is 21. There are ways to do this on the calculator. It's not faster. Example 5. An arithmetic sequence has a 5th term of 18 and an 11th term of 27. Find the common difference, the first term, and the general term. Okay. So this is where it gets IB level. A sub 5 equals 18. So that means 18 equals my first term plus my difference times 5 minus 1. So I can simplify this to be 18 equals 5d plus a1. No, not 5b, 4d. 27 is my 11th term. So 10d plus a1. So now I've got a system of equations. I think I'll solve by elimination. So I'm just going to make all of these negative so the A1s eliminate. And that will give me, and just add them together, 27 minus 18 is 9. D equals 9 divided by 6, or 3 over 2. To get my first term, I'll plug it in. I'm going to use the 18. That's 6. 12 equals A1. You will do a lot with these with systems, where you will have to write equations and use systems. Otherwise, this would be an Algebra 1 topic. Maybe by the time we get here, Algebra 2, pretty easy pre-calc. For series, we are adding together all the terms in the sequence. And we can use this sigma notation. Okay? U sub I is just a formula to get that particular U with the counter variable I, and it goes to N. You should have seen this before by now, but there's where I'm starting at 1. U sub I is my formula. Go to N. So U sub 1, what I get when I plug the formula. U sub 2, and I am adding them all up. That's one of the keys to sigma notation. So, simplify this. Well, that's the first 5 terms. There isn't much of a simpler way to do this other than to take and do all of them. So, I plug in 1. 2 times 1 plus 1 is 3. Plus, um, next one, 2. 2 times 2 plus 1 is 5. Plus, 2 times 3 plus 1 is 7. Plus 9 plus 11. So when I add all of those up, I get 20, 27, 32, 35. My next one's going to be a little bit harder, but I'm starting with 4. 4 cubed is 64, minus 16 is 48. Now I got to go to 5. 5 cubed is 125, minus 25 is 100. 6. 6 cubed, I think, is 216. But I'm going to check this with the calculator. And yes, that does give me 180. 7. Now's where they're getting big. 294. When I add all these numbers up, I get 1070. Okay, arithmetic series. An arithmetic series is a series made up of an arithmetic. The things added together are the parts of the arithmetic sequence. This formula is lovely. This is known as Gauss's formula. Carl Friedrich Gauss is probably known as the smartest mathematician of all time, or commonly thought of as that. He came up with this version of this formula, maybe. The story goes, though, that Gauss was smarting off in class, like any genius child. Thought he was smarter than his teacher. Maybe he was. But so as punishment, this is just like an elementary school kid, his teacher told him that before he went out to recess, he had to add all the numbers up from 0 to 100, or from 1 to 100, I guess. 0 to 100 would be the same thing, but so he walks up to the board and writes this down. What's his trick? Well, he added 1 plus 100, 2 plus 99, 3 plus 98. All of these numbers equal 101. That's the first number plus the last one. How many are there? 50. That's the n over 2 part. This first plus last. 50 times 101 equals 5050. Okay, if you want, you can watch the proof video that's here. We're just going to go through a few examples and then we'll get going. So find the sum of the first 12 terms. Okay, so I use my sum formula. There's 12 terms, 12 over 2, 135 plus 3, so 6 times 138 is 828. That's pretty easy. You won't get that on an IB exam. It's too easy. So now we have an arithmetic sequence given by this. Find the sum of the first 10 terms. Okay, so first thing I need to do is get u sub 1. Then I need to get u sub 10. That's negative 103. This is 59, I think, yes. So the first 10 terms, use the formula, 10 over 2. I suppose I should put that in here. They will like this better if you notate it. And when I stick that into a calculator, I get this. Yes, it is a negative number because, well, most of the numbers that I was adding up were negative, and there was more of it that was negative than positive. Okay, example 3. An arithmetic sequence has a first term of 20, a common difference of 13. Identify which term is equal to 228. Then find the sum of the terms 20 to 228. Sometimes they might not give you the first question, and they'll just ask you to do the second, but you will need to do the first to get there. So first term of 20, a common difference of 13. And that is equal to 228. I need to figure out which term this is. So I will solve. And I get n minus 1 is 16. That means n is 17. So this is the 17th term. If I want the sum, I do 17 over 2, 20 plus 228. And I get 2108. Now's when they're going to get a little bit trickier. The arithmetic sum of the first n terms is given by this. Find the first term and the common difference. Okay. So that looks a lot like the sum term, right? The sum formula is this. Or no. Okay. So we know the first term. The sum of the first term in the series is the series value. So n over 2, I guess I can do that as a 1. I can plug in a 1. 1 over 2, 5 times 1 minus 11 equals, I can also use the A1. So that is my first term. So A1 equals -3 when I simplify that. The sum of the first n terms. So now I've got n over 2, 5n minus 11 equals, if I use that, use my -3 in this formula right here for u sub 1, I'm going to do a little bit simplifying there. Those will cancel. Go to black for a second here. So 5n minus 11. Oops, I don't need the parentheses. Equals -3. U sub n. I guess I'm still using the A that I've used in the past. They use U in Cognity. Well, I know it's -3 plus D times N minus D. So, oh, I missed a little trick here. I need to find the common difference. Now, here's a trick. I can do S sub 2 equals 2 over 2, 5 times 2 minus 11, which is -1. So the sum of the first two terms is also u1 plus u2. So I know S2, I should just substitute it in, is -1. Know that from right there. I know u1 is -3. When I solve this, u2 is 2. Okay? So u2 is 2. I plug in and I get D. I'm using this formula with you too. That's -3 plus D. D equals 5. So now I've got -3 plus UN. UN is going to be U5 here equals -3 plus 5. No, 5 minus 1. So again, I'm still using that formula that I got right here, but now I'm plugging things in. U sub 5, 5 is D, n minus 1 is 5 of 4, so this is 17. I guess I didn't need to go through this, back through this. All I needed to do was find U1, find the first term, U1 equals -3, D equals 5. I could plug this in. 5 times 5 minus 11 equals -3 plus 17, and that's true, those both equal 14. So tricks like knowing things add together is very helpful. And now this one is going to get a little more complicated. An arithmetic sequence has a third term of 11, and the sum of the first 10 terms is 160. So find the first term, the common difference, and the general term of the sequence. Okay, the general term is going to be the formula. Third term is 11. I'm going to start by writing down what they tell me. S10 equals 160. So I know 11 equals U1 plus D times 3 minus 1 or 2, 2D. I also know 160 equals 10 over 2, so 5, U1 plus U10. I know U10 equals U1 plus 9D. Again, when I plug in. So I've got 160 equals 5, U1 plus U1 plus 9D. First term, common difference. 160 divided by 5, I think is 32. Yeah, that's right. Now I've still got two variables that I don't have solved for. Oh, I can take this equation right here and combine it with this equation. I'm going to negate the second one. And add. Oh, I need to double the first one too. I'm not doing this solving very efficiently. Let's just write that down here. 22 equals 2u1 plus 4d. Yeah, that'll work better. Negative 5d. D equals 2. I'll take my first equation, plug in my 2, u1 is then going to equal 7. So, answers. I'm not done quite yet. U1 equals 7. D equals 2. General term of the sequence equals 7 plus 2n minus 1. Sometimes they will simplify this to be 7 plus 2n minus 2, which is 5 plus 2n. Okay, last one. And then you are done for today. Consider the sequence Sn equals 2n squared minus 3n. Find the expression for the general term un and show that this is an arithmetic sequence. So, we know that if this is an arithmetic sequence, the nth term is the sum minus the previous sum. So it's the sum of, so let's pretend it's the 10th. The 10th term would be the sum of the first 10 minus the sum of the first 9. Because the 10th term is the sum of the first 9 plus the 10th. Okay? So, we know that, hold on a second. I need to pause. I will come back and finish this.
Wait for it.
No, that's okay.
If you want, I will wait longer. It's fine.
Yeah, give me about 5, 6 minutes to finish recording. I'm recording a video because I don't have enough time to teach all my lessons sometimes.
Yeah.
So, okay, thanks. So, consider this sequence. Well, I know S sub n. So much of this class is about being able to use formulas. Sn minus 1, I just plug in n minus 1. Okay. Nothing rocket science here. Now I just got to do some algebra. Um, so I distributed the negative and the 3 here. Now I got to square this. N minus 1 squared is n squared plus 2n plus, or minus 2n plus 1. And I got to double it and negate it. So plus 2 minus 2. Okay. Now when I combine like terms, a few things cancel. Wow, a lot of things cancel. I missed an n when I squared the n squared minus 4n. Okay. And oh, that's a negative. There's three minuses. I'm trying to simplify too much too fast. So I get this is also a plus. Okay, I should have written it out. Negative 2, n squared minus 2n plus 1. This becomes a plus 3n minus 3. Okay. Yep, that works. So now I get 4n minus 2 minus 3 is minus 5. That is u sub n. I also know the next term, un plus 1 minus un. So un plus 1. Now I've got the formula for u sub n. I suppose my common difference is 4. Is that all it asked me for? Find an expression for the general term. Okay, I've got to get the general term. So this is probably not how I would do it, but this is how the book is doing it. 4n plus 1 minus 5 minus 4 and minus 5. You end up with 4. You can tell always this is the formula for the general term. It's not in its standard way, but common difference is multiplied by the n, or the n minus 1. So the common difference is 4. My general formula is u sub n equals 4n minus 5. And that is the end of this lesson.